Question 36. Identify the domain and range of the following function. So the first thing we will look at is the domain. And the domain are our possible x values. And in this particular function, when we're doing a rational function, we want to look at the bottom. And we think, is x squared plus 1 ever equal to 0? And if we try to solve this, we'd get x squared equal to negative 1. And we have a squared on the left equal to a negative on the right, and that's never going to happen. So there actually is no restriction on our domain. We will never get a 0 on the bottom, right? If you want to look at it this way, x squared is always positive. We're adding 1, that's always positive. So x squared plus 1 is always positive. So our domain is negative infinity to positive infinity. So there's no restrictions on x. So now on the topic of x squared plus 1, we want to think about how that behaves so we could analyze the range here. So if you remember x squared plus 1, it's just a parabola that's shifted up 1 unit. So the minimum value, the minimum y value is y equals 1. So that happens when x equals 0. Now, because this is a reciprocal graph, our minimum value is going to become a maximum value. So when we're discussing the range, when x equals 0, we get f of 0, which is 3 over 0 squared plus 1. So that's just 3. So a minimum will actually correspond to a maximum right here. So our maximum is 3. And we can also think about what happens when x gets really, really big. As x gets really, really big, f of x, right? 3 divided by something really, really big. 3 divided by something really big goes to 0. So when it comes to our graph here, our minimum is 0 and our maximum is 3. When we write out the range, of course you put the smallest first, so that's a 0. You put the 3 next. It actually does take on the value of 3. The graph approaches 0. So we want to have a round bracket around 0 and a square bracket around 3. To make this a little bit more easy to understand, I think I'm going to try to graph this function. So the first thing, I already have graphed, I've already graphed in blue, which now I'm using red, but I've graphed x squared plus 1. In black, I'm going to graph 1 over x squared plus 1. So I'm going to graph 1 over x squared plus 1. So that is a reciprocal graph. So the reciprocal of 1 is 1. That stays the same. And to complete this graph, these big y values will become small y values. The big y values over here will become small y values. The really large y values will become really small x values. So it kind of has this shape to it where it gets close to the axis. And that's probably not a great representation, but remember, when it comes to reciprocal graphs, the reciprocal of a big positive number is a small positive number, and it approaches 0. Right? The 1 will stay the same. So if we're looking at the range of this particular graph right here, right, its range is from 0 to 1. So the range of this black graph is from 0 to 1. And the 3 is really just a vertical stretch. So this is, we could write this as f of x equals 3 times 1 over x squared plus 1. So this 3 right here would represent a vertical stretch by a factor of 3. So all it would do is it would triple all these y values. So instead of it going to a maximum height of 1, that would get tripled, and it would go to a maximum height of 3. It would still have the same shape as the other graph. So it would still kind of do this asymptotic shape. This is not my best graph, but I think it further explains why the range is from 0 to 3. I think this is a hard 2-mark question, but you really got to understand reciprocal functions, and you have to understand restrictions on the range.